In this video, I'm going to show how to add individual elements to a heap. Here we have a heap. It's a max heap because each root is greater or equal than the children. And we have a number of elements that should be added one at a time. So let's start by adding the first element, 22. The way we add elements individually is we find the end of the last level. So here I start at the root, I go down, end of the last level is right here, 12. So there is no possibility to add more because this is a binary heap. So each parent has only a maximum of 2 children. So we need to add a new level here, which is the left child of 10. And we're going to add 22. So starting by adding the new element at the very end of the last row or advancing to a new row or level is important because that maintains the requirement of a heap to be a complete tree. So here we have 22. There's one problem. The heap property that the parent needs to be greater or equal than the children in case of a max heap is now broken. If I look at the parent, 10 is no longer greater or equal than the child, 22. So 22 is added at the last row, and now it needs to swim up long enough to ensure that the parent is greater or equal than both children. So in this case, 22 needs to swim. As 22 swims up, then comes down. Let's make that happen. 22 swims up, then comes down. Now I have to ask myself, am I done swimming? Here is 22. The parent, 34, is greater or equal to 22. That's awesome. Next element, 36. I find the last level and place the new element in the next position. So here I can add a right child, 36. And I'm going to ask myself, does it need to swim? And 22 is not greater or equal to 36. So yes, we need to swim. 36 swims up, 22 comes down. At this point, I'm asking myself, am I done swimming? I need to check the parent of the new element that is in the process of swimming. So 34 is not greater or equal to 36. So 36 has more swimming to do. 36 goes up and 34 comes down. So here I'm looking at 36. Am I done swimming? I'm checking the parent. And I see, yes, the parent is greater or equal to 36. We are done. Let's take the next one, 16. And at this point, I encourage you, pause the video, try it yourself, press continue when you did it. So here, I'm going to show you how I'm going to add 16. I find the last row, find the next position. It's going to be right here. And now I need to check with the parent whether any swimming is necessary. The parent is already greater or equal to 16. So awesome, I'm done. Next element, 40. Again, pause the video, try to do it yourself. When you're done, press continue. So at this point, I'm going to enter 40. I'm going to find the last row, find the next position. Next position is 40. And I'm checking, do I need to do any swimming? 32 is not greater or equal to 40. So yes, I need to do some swimming. 40 swims up, 32 comes down. And I'm asking myself, am I done swimming? What about 40? I check the parent. Is 36 greater or equal to 40? No, this is not the case. So 40 keeps swimming and 36 comes down. Here is 40. Here is 36. Very important that we keep asking ourselves whether we are done swimming or whether more swimming is needed. I'm checking with the parent of 40, that is 50. 50 is greater or equal to 40, so that is good. We found the right position. We're done adding 40. I look at the next element, 54. Again, pause the video, try it yourself. When you're ready, I'll show you. 54, last row. I find the next position right here for 54. And 54, I notice, is not in the right position because 24 is not greater or equal. So 54 needs to swim up and 24 is coming down. Now I have to check, is 54 done swimming? No, we're not, because 28 is not greater or equal to 54. So 54 keeps moving up and 28 comes down. At this point, I'm asking myself again, am I done swimming? So 54 is right here. I check the parent. 50 is not greater or equal to 54. So 54 needs more swimming, and 54 swims up and 50 comes down. At this point, I look at the parent of 54 and I realize there is no parent because this is the root of the tree. So we are done swimming. This is it. 54 is the new biggest element in my max tree. Now keep in mind, heaps and priority queues can have duplicates, so there could be other 54s. In my case, that is not the case. So here I'm done entering 54, and I have one last element that needs a position, that is 30. So I'm going to go to my last row, find the last element, going to add 30, and if you haven't paused the video yet, I encourage you to do that. And at this point, I'm going to check whether I need to swim. So 28 is not greater or equal to 30. So let's swim up 30 and 28 comes down. And I'm going to look at the parent. Is 50 greater or equal to 30? That is the case. So at this point, I am done. This is work you would do on a scratch paper. But now we have to tell Canvas what we did. And the way we do it is we provide the array that shows how this heap is stored. The first element is empty, so we signal that with an underscore. And then we list all the elements level by level, separated by a space. So here I would start with the root 54 and a space and 40 and a space and 50 right here and a space. Next level, continue here with 34, etc. I'm going to pause the video. And here you can see all the elements in order, in level order. And that is what you would enter into Canvas.